Now we're going to go over related conditionals. Related conditionals are statements that are based on that given conditional. So for example purposes, we're going to use the conditional we used in the previous video. P implies Q, where P is that it is raining and Q, I wear a jacket. So the conditional. P implies Q. Given this hypothesis, we come to this conclusion. So if it is raining, then I wear a jacket. Next, we're going to go over converse. The converse is that the conclusion implies the hypothesis. So that would be, if I wear a jacket, then it is raining. Next, we're going to have the inverse. The inverse is not P implies not Q. That's saying if it is not raining, then I do not wear a jacket. Finally, our last related conditional is the contrapositive. And that's saying that not Q implies not P. And that's saying if I do not wear a jacket, then it is not raining. So we have a conditional, P implies Q. Then related conditionals, the converse, Q implies P. The inverse, not P implies not Q. And the contrapositive, not Q implies not P. Let's look at one big truth table for all of these. So our first statement P, then Q, then we're going to do the conditional, P implies Q, the converse, Q implies P, the inverse, not P implies not Q, and the contrapositive, not Q implies not P. I'll go ahead and fill in the first three columns since we've done those in the last video. So for the conditional, it's false only if a true hypothesis implied a false conclusion. So now, let's look at the converse. If both are true, true implying true is true. False implying true, remember, Q, our conclusion, is taking the place of our hypothesis. So false implying true is still acceptable. However, true implying false is still false. You cannot have a true hypothesis imply a false conclusion. In the case of the converse, our Q becomes our hypothesis and our P becomes our conclusion. Therefore, this is false, and then false implying false is true. So now we're going to look at not P implying not Q. So let me go ahead and add not P and not Q so that the truth values are easier to see. So remember, the negation has the opposite truth values. So when they're both true, not P and not Q are false, and then the others are flip-flopped. So, not P implying not Q means that false is implying false, which is true. In the next one, we have a false implying a true, which is true. And then the next one, not P implies not Q, we're going to have a true implying a false, which we know is false. You cannot have a true hypothesis imply a false conclusion. And then finally, true implying true, which is true. Now we're going to go to not Q implying not P. So not Q will be our new hypothesis and not P will be our new conclusion. So for the first one we have false implying false. The next one we have true implying false. You cannot have a true statement imply a false statement. Therefore, this is false. Then we have false implying true and true implying true. So now let's go ahead and erase these first 4 columns and focus on the last 4 columns, the conditional and the related conditionals. If you can see, true, false, true, 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 false, true, true. The conditional and the contrapositive are logically equivalent. And logically equivalent means that they share the same truth values. So these two, the conditional and the contrapositive, share the same truth values. If you notice, there's 2 more if-then statements that also are logically equivalent, and that's the converse and the inverse. True, true, false, true. True, true, false, true. So the converse and the inverse are logically equivalent, just as the conditional and the contrapositive are logically equivalent. And in order for them to be logically equivalent, they must share all of the same truth values.